An algorithm is a set of instructions designed to perform a specific task. Think of it as a recipe in a cookbook. Each step in the recipe needs to be followed to achieve the final result. In computing, algorithms process data to solve problems or make decisions. Algorithms have key characteristics. They are precise, meaning each step is clearly defined. They are finite, which means they have a clear starting and ending point. Algorithms are also general, so they can handle different types of input. Finally, they are unambiguous, meaning their instructions are clear and do not leave room for interpretation. In healthcare, algorithms are used in various ways. For example, they help in scheduling patient appointments. They also play a role in diagnosing diseases based on symptoms. Understanding the basics of algorithms is crucial for modern healthcare. Nurses may not write algorithms themselves, but they interact with systems that use them. Knowing how these systems work can improve patient care. For instance, an understanding of algorithms can help nurses better use electronic health records, or EHRs. Sorting algorithms arrange data in a specific order. One common example is the bubble sort algorithm. It repeatedly steps through a list, compares adjacent elements, and swaps them if they are in the wrong order. This process continues until the list is sorted. Imagine sorting patient records by name or date of birth. Another example is the merge sort algorithm. It divides the list into smaller sublists until each sublist has one element. Then it merges the sublists to produce sorted lists. Merge sort is more efficient for large datasets compared to bubble sort. Search algorithms, on the other hand, help find specific data within a list. A simple search algorithm is the linear search. It checks each element in the list one by one until it finds the target. Consider looking for a specific patient's file in a stack. The binary search algorithm is more efficient but requires the list to be sorted. It repeatedly divides the list in half, comparing the target with the middle element. This method quickly narrows down the search range. Binary search is useful in large databases. Understanding these algorithms helps nurses appreciate the tools they use. For instance, grasping how search algorithms work can help in retrieving patient information faster. This knowledge improves efficiency in healthcare settings. Machine learning, or ML, is a type of artificial intelligence AI. It allows computers to learn from data without explicit programming. Think of it as teaching a computer to recognize patterns. There are three main types of machine learning: supervised, unsupervised, and reinforcement learning. Supervised learning uses labeled data. The algorithm learns to map inputs to outputs. An example is a system that predicts patient outcomes based on historical data. Unsupervised learning deals with unlabeled data. The algorithm tries to find hidden patterns or structures. Clustering is a common unsupervised learning technique. Reinforcement learning is about learning through trial and error. The algorithm receives feedback from its actions and adjusts accordingly. This type of learning is useful in designing personalized treatment plans. Understanding these types helps nurses see the potential of ML in healthcare. Section 4. Simplified healthcare-related examples of machine learning. Supervised learning can be seen in predictive analytics. Imagine a system that predicts the likelihood of a patient developing a condition based on their medical history. The system uses labeled data, like past patient records, to learn patterns and make predictions. Unsupervised learning is useful for clustering patients. For example, an algorithm might group patients with similar symptoms. This helps in identifying commonalities and creating specialized treatment plans. It is particularly useful in managing chronic diseases. Reinforcement learning can optimize treatment plans. Consider a system that suggests medication dosages. It learns from the patient's response to previous doses and adjusts recommendations. This leads to more personalized and effective treatments. These examples illustrate the practical uses of machine learning in healthcare. They show how algorithms can assist in patient care and decision-making. By understanding these applications, nurses can better utilize technology in their daily work. Section 5. Deep learning and neural networks. Deep learning is a subset of machine learning. It involves neural networks with many layers. These networks mimic the human brain. Each neuron in a layer processes data and passes it to the next layer. This structure allows the network to learn complex patterns. Neural networks require activation functions. These functions determine whether a neuron should be activated. Common activation functions include the sigmoid and ReLU functions. They help the network learn nonlinear relationships in data. Training a neural network involves feeding it data and adjusting its weights. The network makes predictions, and errors are measured. These errors are used to update the network's weights through a process called backpropagation. This cycle continues until the network performs well. In healthcare, deep learning can analyze medical images. For instance, neural networks can detect anomalies in X-rays or MRIs. This assists radiologists in diagnosing conditions. Deep learning also aids in speech recognition, enabling voice-activated medical records. Section 6. Applications of deep learning in healthcare. Image recognition is a key application of deep learning. Neural networks can identify diseases in medical images. For example, they can detect tumors in MRI scans. This improves diagnostic accuracy and speeds up the process. Speech recognition is another application. Deep learning models can transcribe doctor-patient conversations. This helps in maintaining accurate medical records. It also allows healthcare providers to focus on patient care instead of note-taking. Predictive analytics benefit from deep learning. These models can forecast patient outcomes based on historical data. They analyze complex patterns that simpler models might miss. This leads to better treatment plans and improved patient care. Understanding these applications is crucial for nurses. It shows the impact of AI on healthcare. By embracing these technologies, nurses can enhance their skills and provide better patient care. Staying informed about AI advancements is essential for the future of healthcare.